episode 12 of Trying to Learn C. I'm going to continue from where I stopped. If you don't know what is happening, I'm trying to learn C and I have 50 programs here that I am going to create in C. So far I have done 18 and I'm going to continue from number 19, swapping two numbers using pointers. So let me open up my development folder, and then inside the C tutorial, so these are all the projects. So I just create a directory called pointer swap, yes. So I cd into pointer swap, then I use new vim as my text editor. So just open up create a main file and open it. Then my main function. Okay, then what I'm going to do, swap two numbers using pointers. So I will just create a function swap that takes in two numbers, let's say a and b. Then here I can define a and b. Int a is equal to 10, comma b is equal to 15. So I want to swap them. Then here I can create my swap function which takes in int a and b. Okay, so this is the basic boilerplate, and let me just look at pointers. This website is actually one of the best C by examples, so whenever you want to learn a new concept, you can just come here. A pointer is a variable that can hold the address of another variable. Just like regular data types, they must have their own type, which refers to the type of the data the address pointed to. So this is how okay, so this is what is used to define pointers. And then alright, so pointers hold addresses to other variables. So you can see the pointer xptr, x pointer, it is holding the address to position 0 in array x. That's the first element in this array. So how do I do this swap? Let me try something. So you can maybe like int pointer to a would be equal to ampersand, then it takes in a. Alright, here asterisk. Then you can do int pointer to b ampersand b, which will take in ampersand b. Then I can do, then what do I do from here? Okay, let me just printf, then you go a is equal to %d, new line, b is equal to %d, new line. Then you can just print a comma b. Alright, so to do the swap, do I have to create a temporary variable? Maybe int temp would be equal to pointer to a. Okay, no, what am I even doing? No, a is the address. Currently a is the address. So I have to point to that address. So I can do something like I'm coming. So okay, this doesn't work. All right, temp would point to the address of what? It would point to this, and then you can do ptra is equal to, I have no idea what I'm doing really. Then ptrb temp, do I go like this? No, I'm coming. I actually have no idea what I'm doing. Pointers in C. Okay, so you have this. Let's say a is equal to 10. Then pointer can take in the address to a, and then to print that value, you point to this. Okay. So I think here is supposed to. How am I supposed to point to be? Let me just see what is the fix. Then ptrb is equal to temp. Then do I point to temp? To the address of temp? Does this work? Main.c. A is equal to 10, B is equal to 15. Okay, that did not work. Oh wait, do I come here and do maybe pointer or address? No. Okay, how do I do this? I actually have no idea. Pointer B. Okay, accessing an integer value using pointer. Value at. Okay, this is it. Wait, here am I supposed to print ptr? Is this what I'm supposed to do? Maybe I do this. No, at this point I'm just doing a bunch of trial and error. So let's see. Okay, that worked. That was okay, that worked. So if I print just a and b, I am still accessing these variables, and I got that from here. So you can see declare pointer variable, then note that data type of pointer and variable must be the same, which is this, int and int. Then the pointer here will take the address to a. So value the to get the address, that's to get the address, you do this, which is percentage p, the pointer, value at pointer, then value at a, which is your a, then value at pointer to a. You have this. Okay. Okay, I think that solves the problem. So I can just do let's say int, and maybe return a. Wait, I actually don't know this, but how do I return two values in C? Like this. Does this work? Let's see. Let's see whether it works. So let me just remove this, and then we can do why do I keep doing that? Printf, then we can do %g. Will this work? So let's see. 15. Okay, 50. Now it was only A that got returned. So how do I actually return two values? Return multiple values in C. Okay, let's see how to do that. Also open this. Declare a struct. What the heck is a struct? Structure. What? I think I know how this structure works, but let's just build using pointers, structures, and arrays. Compare AB at great at small. Okay, so I can just do int a comma b. So okay, I think that I should actually do that to save. So I can come here. Let me try this outside. I want to see whether I saw something now that if I do pointer to A, what did I just see? Create small xy. Address to create small xy. Okay, that was not it. Create small xy. This is what I'm supposed to do. Int underscore A underscore B. Okay, then I come here. Yeah, I should take in the addresses p tr underscore a. Yes, which is, oh, it's taking a pointer. Underscore a int underscore b. Okay, so here, when you come here, now we can pass in the addresses. Then here we can just remove this. So A is 10, B is 15, and if we run this, we should get, oh my god. What the heck? What the heck was that? Did he print out the addresses? Pointer. So this is what I'm supposed to do. This is actually, I think I'm just going to learn structs, because what is this madness? A is equal to 10, B is equal to 15, so it not swap. A is equal to 10, B is equal to 15, then you can do I am actually just going to learn structs, because well, what I don't even know what I'm doing. Let me just see swap on numbers using pointers in C. Oh my god. Let me see how. Let me just take my thing back to where it was. Okay, this is my working program. It is loading. It is loading. Okay. Oh. Wow. So I could have. So. Oh. So since the beginning, I can just take in. If I do this, let me just. A pointer. Okay. So here, instead of passing just the values, I can just pass the address to the values if I do this. Alright, then 10, then this would take in the pointers, then pointer to A will be equal to pointer to B. I actually have to sit down and understand what I'm doing. Pointer to B is equal to temp. So this just works. Let's see whether our A would be equal to 15. Oh, this works. Okay. So what happened? is that instead of passing the values themselves, I think if you instead of passing the values themselves, I can pass the address to the values because the address doesn't change. So wherever in the program, if that address is referenced, it is going to be it is going to be for these variables. So if I pass in the address of A and the address of B, how do I capture that with pointers? So pointer A can hold pointers hold addresses. Yes, that's the correct term. Pointers hold addresses. So this parameter, so the first parameter is to hold address to A, the second one hold address to B. So you can only pass in address. So this is it. And then here you just do temp is should point to whatever your A is, the value, and how you access a value from the address is using pointers. So you do pointer A, you can access it, and then you do the assigning, you swap. Okay, I think now I understand. I think that's it for this. So I can just add it and then git commit pointer swap done, git push, then you can come here, done. Write a program to dynamically allocate memory of an array and initialize it using pointers. Oh, I have no idea what that meant. Well, let's see. So this is my array. Write a program to allocate memory for an array and initialize it using pointers. The reference. So let me see how to do that. Dynamically allocate memory to array. Allocate dynamically allocate memory to array. Okay. Oh my god. Okay. Write a program to dynamically allocate memory for an array and initialize it using pointers. Use memory allocation functions like malloc, calloc, and realloc. What? Malloc allocates a single contiguous chunk of heap space of the past size. And it is taking forever to load. Oh my god. Oh, so this is how to do it. So this is basically the dynamically allocate memory for an array and initialize it using pointers. So I'm coming. So let me just dynamic memory dynamic memory, dynamic memory. So you can just do, let's say, int array is equal to malloc. I need to know more about this function. Alright, yes, this is what I've been looking for. Since C is a structured language, it has some fixed rules for programming. One of them includes changing the size of an array. An array is a collection of items stored at contiguous memory locations. So the array length here is 9, which is here. First index is 0 and last is 8. The length size of the array is 9, but what if there is a requirement to change this length? For example, if there's a situation where only 5 elements are needed to be entered in this array, in this case the remaining 4 indices are just wasting memory, so this is a requirement to lessen the length. Take another situation, there are 9 elements and fill, but we need 3 more, so we need to change the size from 9 to 12. Dynamic memory allocation in C. Dynamic memory allocation using malloc, calloc, and free and realloc is essential for efficient memory management in C. If you are looking to master these concepts and the application data structures, alright, that's not what I'm looking for. C memory can be defined as a procedure in which the size of the data structure like array is changed during the runtime. C provides some functions to achieve this task. There are 4 library functions: std, the standard library.h, malloc, calloc, free, and alloc. So if we have the malloc is in C, sorry about that, is used to dynamically allocate a single large block of memory with a specified size. It returns a pointer of type void, which can be cast into a pointer of any form. What? So it returns a pointer type void, which can then be cast into a pointer of any form. It doesn't initialize memory execution time, so that it has initialized each block with the default garbage value. So since the size of an integer is 4 bytes, these statements will allocate 400 bytes of memory, and the pointer ptr holds the address for the first byte in the allocated memory. Okay. So this is what 20. So it holds 5 elements. These pointers will hold the base address of the block created, which is pointer here, and check if the memory has been successfully allocated by malloc or not. Okay, I think let me try something. So that's exactly what I'm going to do. Users to specify the number of elements in an array and impute them. So you can just do, so we can do printf enter size of array, then So here we can just do int n, which will store the size of the array, scanf %d, the address of n, enter size of array. Okay, then to create the array, then we can do int. So it is a pointer. The reason why we need this pointer is if we use malloc, it returns void. So we need a pointer to capture the value. It was stated here somewhere. Okay, it returns pointer to type void, which can be cast into a pointer of any form. So that's exactly what I'm saying. So you can just do ptr is equal to int. Is that how to do it? Okay. Then we do n times size of int. Okay, is this it? Yeah. So then we can do something like int printf enter array elements. Let me add new line here. New line. Okay. Then new line. Okay. Before I enter array element, I need to see whether the memory allocation was successful or not. Then we can do if ptr is equal to null, printf memory allocation unsuccessful, memory allocation unsuccessful. What is that up there? Memory allocation. Then I can just exit. Else, do I need an else? Okay, then every other thing goes inside the else. Okay. Else. So this is it. So enter array element. Then we can do for int I is equal to 0, I is less than I is less than what? Oh, n, of course. How did I plus plus scanf percentage, then percentage d, new line. So where is it getting stored? Inside bit here of I. So it should be the address. Yeah. So let's since this, let's assume we put 5 here, so we are going to get memory size 20 of 20 bytes, and each 4 bytes, that will put one variable, and you just, yeah, just some Then let's print the array 3D. Let me just copy this. Then we can just do printf. So will this work? Moment of truth. So decrease the executable, enter size of array 5. What was that? Why did I hook? Size, enter size of array, then I imputed 5 and pressed enter. And why did it hook? What was that? So let me just print a new line here. Just make it a bit readable. So I want to know, why does it, I'm coming, enter. So is it because of the new line? Let me just try 5. Okay, then array elements 23, 32. Enter 1, 2, 3, 4, 5. Okay, I think it's because of the new line. Something about it that is very weird. Then let's do 5, enter array elements 12, 34. That's this. Okay, enter array elements. Okay. But wait, this is not getting any values from the user. What? I'm coming. So what happens here? 5. Oh, so it is just assigning them. Yeah, it is just assigning them. And what I did was collect them from the user. Oh, is this the reason why? Is this the reason why? I actually still don't know the difference between using plus plus I and I plus plus. I just always use I plus plus and it works like magic. So let me just try this. 5, enter array elements 23, 12, dot 12, 3. Okay, so it's basically the same thing. So that's it. Write a program to dynamically allocate memory for an array and initialize it using pointers. So that's how it is. So from the standard library, you get malloc and you just do int. This is, what did they even call it? It like catches the void cast to a pointer of any form. So this is the cast type int. And let me just try something. Yeah, this will not work because I think because this will not work, and because the cast type here is int and here your pointer is a character, so it has to be the same. Int it, then you do malloc memory allocate, then you do n times size of n, then you can access this is just your array. Yeah, that's your array. So that's for the memory allocate. Yeah, so that's it. So let me just quit, then commit dynamic memory, done, and push it to GitHub. Then here I can do done. I think that's it for today. I will continue tomorrow, so see you then. Bye. Peace out.